My dear students, welcome back to our channel. In this video, I will be explaining the Bachelor of Computer Applications 4th semester subject Network Security as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1, the important short question is 1. What is cryptography? Cryptography is the art of hiding information so that only the right person can read it. It keeps your messages and data safe from hackers. Example. Imagine you write a secret message to your friend using a code like "Meet me at 5" becomes NGGV OG CV5 letters shifted by 2. Only your friend knows the trick, so only they can read it. This is a basic form of cryptography. In real life, cryptography is used in WhatsApp, online banking and shopping websites. It locks your data using a secret key, so even if a hacker sees it, they can't understand it. Two main types. 1. Symmetric key, one key for both locking and unlocking. 2. Asymmetric key, one key to lock, public, one key to unlock, private. Easy to remember. Cryptography is equal to secret code plus key. Like a digital locker, only the right key can open it. Next important short question is 2. What is steganography? Steganography is the technique of hiding secret information inside something normal, so no one knows a message is there. It's like secret writing. Example. Imagine you hide a message inside a photo. The photo looks normal, but only your friend knows how to open it and read the hidden text. Others just see a regular picture. In real life, people use steganography to hide data in images, audio, or videos. It helps send secret messages without anyone guessing that a message even exists. Difference from cryptography. Cryptography hides the message's meaning. Steganography hides the message itself. Easy to remember. Stego is equal to secret go, secretly send info by hiding it inside normal files. Just like hiding a note inside a lunchbox, steganography hides data inside everyday things to keep it safe. Next important short question is 3. What is symmetric cryptography? Symmetric cryptography is a method of locking and unlocking a message using the same secret key. Both the sender and receiver must know this key. Example. Imagine you write a letter in a secret code and lock it in a box. You give the key to your friend. They use the same key to open the box and read the letter. That's symmetric cryptography. In real life, it's used in apps, Wi-Fi security, and older file encryption tools. How it works? You type a message. The message is locked, encrypted, using a secret key. The receiver uses the same key to unlock, decrypt the message. Easy to remember. Same key, secret way. But there's one problem. If someone steals the key, they can read everything. So, the key must be shared safely. Symmetric cryptography is fast and simple, but needs secure key sharing. Next important short question is 4. What is a hybrid cryptosystem? A hybrid cryptosystem is a mix of symmetric and asymmetric cryptography. It takes the best of both to make communication fast and secure. Example. Imagine sending a gift to your friend. You lock it in a box, message, using a fast lock, symmetric key. But instead of giving the key directly, you lock the key using a special lock, asymmetric key, that only your friend can open. Now, only your friend can open both locks and get the gift. How it works? 1. A fast secret key is created, symmetric key. 2. This key is locked using public key, asymmetric. 3. The locked key and message are sent safely. Used in secure emails, WhatsApp, and online shopping. Easy to remember. Hybrid is equal to mix of fast plus safe. Fast like symmetric, safe like asymmetric. Hybrid systems give the speed of symmetric and the security of asymmetric, making them perfect for modern secure communication. Next important short question is 5. What is a digital signature? A digital signature is like an online signature that proves a message or document is really from you and not changed by anyone. Example. Imagine you send a handwritten letter and sign it. The receiver knows it's really from you. Similarly, when you send an email or file online, a digital signature proves it's yours and hasn't been changed. It uses asymmetric cryptography. You sign with your private key. Others check it with your public key. If even one word is changed, the signature won't match. Where is it used? In online banking, e-signing documents, Aadhaar-based services, and government portals. Easy to remember. Digital signature is equal to your online stamp. It proves who sent it and that nothing was changed. So, it builds trust in online communication, just like a real signature, but smarter and safer. Next important short question is 6. What is authentication? Authentication means checking if a person is really who they say they are before giving access to something. Example. When you open your phone using a PIN, fingerprint, or face, you are proving that you are the real owner. That's authentication. In the online world, it is used when you log into Facebook, Gmail, or online banking. Types of authentication. 1. Something you know, password or PIN. 2. Something you have, OTP on your mobile. 3. Something you are, fingerprint or face ID. Many websites use two-factor authentication, like a password plus OTP to be extra safe. Easy to remember. Authentication is equal to are you really you. It helps stop hackers from pretending to be you and protects your data from being misused. Next important short question is 7. What is secret splitting? Secret splitting is a way to break a secret into smaller parts and give those parts to different people. The secret can only be known when the parts are combined. Example. Imagine your ATM pin is split into 3 pieces and given to your 3 friends. One friend alone can't tell the pin. But when all 3 come together, the full pin is revealed. That's secret splitting. It is used to protect very important information, like bank keys, passwords, or private data. Even if one part is stolen, the full secret stays safe. How it works? A secret is divided into many shares. Only a certain number of shares are needed to unlock the secret, like 3 out of 5. Easy to remember. Split the secret, stay protected. Like breaking a treasure map into parts, only when combined, the full path is known. Next important short question is 8. What is secret sharing? Secret sharing is a method of dividing a secret into parts and giving each part to different people. The secret can only be revealed when a certain number of parts are brought together. Example. Think of a treasure map split into 5 pieces. Each friend gets 1 piece. To find the treasure, at least 3 friends must join their pieces. 1 or 2 alone can't find it. This is secret sharing. It's used in banking, cloud storage, and government systems to protect very sensitive data. Why use it? Increases security. Even if one part is lost or stolen, the full secret remains safe. Easy to remember. Share the parts, protect the whole. It's like teamwork, only when the right team members come together, the secret is unlocked. Secret sharing and secret splitting are similar, and both help keep information safe by not storing everything in one place. Next. Long questions. First important long question is: what is a substitution cipher? A substitution cipher is a simple way of hiding a message by replacing each letter or symbol with another one. It's one of the oldest and easiest types of ciphers used in cryptography. How it works? In a substitution cipher, each letter in the original message, called plaintext, is swapped with a different letter, number, or symbol to create a secret message, called ciphertext. Example. Let's say we use a very simple rule. Replace A with D, B with E, C with F, and so on, shifting each letter by 3 places. Plaintext, hello. Ciphertext, HUR, here. HK, EH, LO, LO, OR. Only someone who knows the rule, shift of 3, can change it back to the original message. Types of substitution ciphers. 1. Caesar cipher shifts all letters by a fixed number like +3. 2. Monoalphabetic cipher, each letter is replaced by a fixed new letter, not just a shift. 3. Polyalphabetic cipher uses more than one set of letter substitutions to make it harder to crack. Why is it useful? It's easy to understand and use. Good for learning basic cryptography. Was used in ancient times, like by Julius Caesar. Easy to remember. Substitute to hide. Like playing a letter replacement game, you change the letters to confuse others. Limitations. Easy to break if someone guesses the pattern. Not very secure for modern use, but great for understanding basics. Substitution ciphers are like a secret language between friends. Simple, fun, and a great starting point to learn how real data is protected. Next important long question is: 2. What are one-way hash functions? A one-way hash function is like a digital fingerprint for data. It takes any amount of data, like a message or a file, and turns it into a fixed-size string of characters, a hash. The key thing is that once the data is turned into a hash, you can't reverse the process and get back to the original data. This is what makes it one-way. How it works? Imagine you have a piece of data, like the word hello. A one-way hash function will turn hello into a string like hash hello is equal to. This string is unique for hello. Even a small change in the input, like changing hello to hello, adding an exclamation mark, will result in a completely different hash. Hash hello is equal to. Why is it called one-way? Once the data is turned into a hash, you cannot reverse it. That means it's easy to create the hash, but impossible to turn the hash back into the original data. For example, even if someone knows the hash for hello, they cannot figure out what the original word was. You can't go backwards. Where is it used? 1. Password storage. Websites store a hash of your password, not the actual password. When you log in, they compare the hash of what you enter with the stored hash. 2. Data integrity. Hash functions check if data has been changed. If even one bit is altered, the hash will change, alerting you to tampering. 3. Digital signatures. digital signatures use hashes to verify the integrity of messages or documents. Easy to remember. Hash is equal to digital fingerprint. Just like how fingerprints uniquely identify you, a hash uniquely represents data. Why is it secure? It's fast to compute. Even small changes in the input create completely different hashes. It's a one-way process, so it's hard to figure out the original data from the hash. One-way hash functions are used widely in security systems, especially for passwords, data verification, and digital signatures. Next important long question is 3. What are hybrid cryptosystems? A hybrid cryptosystem is a combination of two types of encryption, symmetric encryption and asymmetric encryption. It combines the speed of symmetric encryption with the security of asymmetric encryption to create a more efficient and secure system for protecting data. How does it work? 1. Asymmetric encryption, public key encryption. First, the system uses asymmetric encryption to securely share a symmetric key. In this method, there are two keys. One is public, can be shared with anyone, and the other is private, kept secret. The public key is used to encrypt the symmetric key, and only the private key can decrypt it. This ensures that even if someone is listening to the communication, they cannot access the symmetric key. 2. Symmetric encryption. Once the symmetric key is securely shared, it is used for the actual data encryption. Symmetric encryption is faster than asymmetric because it uses the same key for both encryption and decryption. The sender and receiver use this symmetric key to encrypt and decrypt the actual messages, ensuring faster communication. Example. Imagine you want to send a secure message to your friend. You first send a public key to encrypt a secret key. Your friend uses their private key to decrypt the secret key. Then, you both use this secret key to encrypt and decrypt the actual message, making the communication fast and secure. This is a hybrid cryptosystem in action. Why use hybrid cryptosystems? Security. Asymmetric encryption keeps the symmetric key safe during exchange. Speed. Symmetric encryption is faster for encrypting large data. Efficiency. It combines the strengths of both encryption methods, providing a perfect balance of security and speed. Easy to remember. Hybrid is equal to safe plus fast. It's like using a strong lock to protect your fast and easy to use key. Hybrid cryptosystems are used in secure websites, HTTPS, email encryption, and online banking. They are essential for protecting sensitive data while making communication efficient. Next important long question is 4. What are digital signatures with encryption? A digital signature is like an electronic fingerprint that proves a message or document came from the right person and hasn't been changed. When encryption is added to digital signatures, it makes the signature even more secure by ensuring both the identity of the sender and the integrity of the message. How it works? 1. Creating a digital signature. When you send an important message or document, you first create a hash, a unique code, of the message. This hash represents the content of the message. You then encrypt this hash with your private key. This encrypted hash becomes your digital signature. The digital signature is attached to the message before it is sent. 2. Verifying the digital signature. When the receiver gets the message, they use your public key to decrypt the digital signature and get the original hash. The receiver then hashes the received message and compares it to the decrypted hash. If both hashes match, it means the message is authentic and hasn't been tampered with. If the hashes are different, it means the message has been altered. Example. Imagine you are sending a secret document to your friend. You first create a hash of the document. You encrypt this hash using your private key, creating your digital signature. You send both the document and the digital signature to your friend. Your friend uses your public key to decrypt the digital signature, compares the hash with the document, and sees everything is intact. Why add encryption? Privacy. Encryption ensures that only the intended recipient can read the message. Authentication. The digital signature proves who sent the message. Integrity. The receiver can check that the message hasn't been altered during transit. Easy to remember. Digital signature plus encryption is equal to secure identity plus safe message. Digital signatures with encryption are widely used in email security, bank transactions, and government services to ensure that communication is both trusted and confidential. Next important long question is 5. What is pseudo-random sequence generation? A pseudo-random sequence is a series of numbers or events that appear to be random but are actually generated by a predictable process. The term pseudo means false, so while the sequence looks random, it is actually created using a specific algorithm or formula. How it works? Imagine you need random numbers for a secure process, like creating a password or encrypting data. True randomness is hard to achieve, so we use a pseudo-random number generator, PRNG. PRNGs start with a seed value, like a starting point, and use mathematical formulas to generate numbers that seem random. The sequence looks random because it doesn't repeat easily and appears unpredictable, but it's generated in a deterministic way, meaning if you know the seed, you can predict the sequence. Example. Let's say you are using a PRNG to generate random numbers for a game. You choose a seed value, say 1, 2, 3, 4, 5. The PRNG uses an algorithm to turn 1, 2, 3, 4, 5 into a random-looking number like 8, 7, 6, 5, 4, 3, 2, 1. It then continues to generate numbers in a sequence that looks random. If someone else uses 12,345 as the seed, they will generate exactly the same sequence. Why is it useful in security? 1. Encryption keys. Pseudo-random numbers are used to create encryption keys in secure communications. While they are not truly random, they are hard to predict, which makes them useful for keeping data safe. 2. Simulations. PRNGs are used in games, simulations, and security algorithms because they provide a good balance of speed and unpredictability. 3. Authentication. For example, generating a one-time password, OTP, for login or transaction confirmation uses a pseudo-random sequence. Easy to remember. Pseudo-random is equal to looks random but predictable. Even though the sequence seems random, it's predictable if you know the starting point, seed. It's like mixing cards in a deck. While it looks random, the process is based on a formula. Pseudo-random number generators are everywhere, from online security to gaming. Next important long question is 6. Write about cryptographic protection of databases in detail. Cryptographic protection of databases. Cryptographic protection of databases is the use of encryption and other cryptographic techniques to secure sensitive information stored in databases. In simple terms, it's like locking up important data inside a safe, ensuring that only authorized people can access or understand it. Why is it important? Databases store critical information, like passwords, personal details, financial data, and more. If someone hacks into the database, they can steal, change, or misuse the information. Cryptography protects this data from unauthorized access, keeping it safe from hackers even if they manage to break into the system. How it works. 1. Encryption. When sensitive data is stored in the database, encryption is used to convert it into unreadable format, ciphertext. Only users with the correct decryption key can turn it back into the original, readable data, plaintext. For example, a password MySecurePass could be stored as an encrypted value like a. Types of encryption. Symmetric encryption. Same key is used to encrypt and decrypt the data. Fast, but key management is tricky. Asymmetric encryption. Two keys are used, one for encryption, public key, and another for decryption, private key. Slower but more secure for key exchange. 2. Hashing. For things like password storage, instead of storing the actual password, databases store the hash of the password. Hashing is a one-way process, meaning it's easy to turn the password into a hash, but impossible to reverse the hash back into the password. If someone tries to break into the database, they will only find the hash, not the actual passwords. 3. Access control. Encryption alone is not enough. Access control mechanisms, like role-based access control, ensure that only authorized users can view or modify sensitive data. For example, only admins should be able to decrypt financial records, while regular employees might only see basic customer details. 4. Data masking. In some cases, certain parts of the data are replaced with dummy data like XXXX for a credit card number to protect sensitive information during processing, ensuring it is not exposed unnecessarily. Example in real life. Consider an online banking system. When you log in and view your account details, your password is hashed before being stored in the database. Your account balance and transaction history are encrypted so that only authorized personnel can access or modify them. Easy to remember. Encryption is equal to lock. Hashing is equal to one-way lock. Access control is equal to who can open. Cryptographic protection ensures that even if hackers break into the database, they can't use the data without the keys or authorization, keeping your information secure. I hope you understand easily each question. All the best, students, for your upcoming exam. For other subject, quick revision. Important questions. Previous question papers and syllabus. Links are available in description. Check out once. Thank you for watching. Like and share this video with your friends.